Bună dimineața, Cluj-Napoca. I hope that was not too terrible. My name is Ramon, and for the next 40 minutes, more or less, I'm going to be talking to you about why you might not need classes in JavaScript. So first, I want to know how many of you actually use JavaScript on a daily basis. Quick raise of hands. OK. Nice. I mean, if you are in this talk, I guess at least you're familiar somewhat. OK, so before we get into the topic, who am I? Well, I'm a front-end web developer from Madrid, Spain. I work at a small startup called Undefined Labs, in which we build developer tools to help teams ship better code faster. We do have a product that is especially useful in microservices architectures, which is something that it's been talked about a lot in this conference. I've been working with JavaScript and React for the past over 4 years, and I really like it. But the thing I love the most is the web in general, the web as a platform. I love its promise of an open medium, accessible to all, and I really like the community around it. I think it's a really nice, welcoming community. And that's partly why I like to go to events and give talks. I also volunteer at Ada Lab, which is a coding bootcamp for women in Madrid. So you probably can already tell that I care quite a bit about community and inclusion in our industry. So since I have a lot of time, let me take a moment to say that one of the things I would really like to see as part of that, as part of community and diversity and inclusion. One of the things I would like to see is conferences stepping up their game when it comes to these issues. So things like having an enforceable code of conduct so that everybody can feel safe, or especially making an active effort to feature more diverse speaker lineups. I think that's something we really need. And some conferences already do that, and it's great, but I really want to see it becoming the norm rather than the exception. So let's try to think about it and do better for next year. And with all that being said, let's get started. So what are we going to talk about today? First, we're going to see why we got classes into the language, a little bit of context and history. Then we'll take a look at some of the most common issues and pitfalls that you might bump into when working with classes in JavaScript. Then we go on to check some alternative patterns to using classes. And finally, we'll review a couple of examples of recent cases of major JavaScript frameworks moving away from classes. So, I mean, so you can see that I'm not only the only crazy person talking about this, and there's actually community moving around this. OK, so why did we get classes in the first place? Well, classes were introduced into the JavaScript language over 4 years ago now. They were part of the 6th edition of the language spec, which was known as ECMAScript 2015. And when we talk about classes, we tend to think about object-oriented programming, right? But it turns out that, as you might already know, there was already a mechanism in JavaScript for object orientation. And it was something that was right there in the language from the very beginning. It's the prototype. So if we already had, prototypes, then why did we get classes exactly? Let's look at an example to figure out some of the reasons. So this is a simple counter. It's written with prototypes on the left and classes on the right. We're going to be using this example along the talk, so give it a look. But it's pretty simple. It just has a constructor that gets an initial value for the counter, and then a method to increment its value, and another one to reset it. It's quite simple. So if you look at these two versions, OK, the class looks a little cleaner, looks a little nicer, but it's not such a dramatic difference, I'd say. However, when you try to do inheritance with prototypes, things get much uglier and messy. Here's a step counter that inherits from the counter we've seen before. It's basically the same thing, but now we get the step of the counter as a parameter. So we are overriding the increment method. And as you can see, we now have to do some weird stuff with prototypes on the left. Whereas with classes on the right, we just use the extends keyword and call super on the constructor, which is much nicer. So based on what we just saw, we could say that we got classes in JavaScript as an improvement over prototypes, at least in terms of syntax. It looks like regular code, like no crazy stuff as with prototypes. But to me, there's probably a more important reason why they got introduced, and it's that classes are familiar for people coming new to the language from other languages. I don't know if you've heard, but JavaScript is become quite popular, so introducing something like classes into the language that are a very common concept in other languages seemed like a good idea. So, okay, classes don't seem so bad, right, from what we've seen so far. There are legitimate practical reasons to have them in the language, and they're definitely better than prototypes. So what's the problem then? Well, there are actually a few problems, so let's go over them. The first and most important one to me is that they create false expectations. We just said that a reason to introduce them into the language was because they are a familiar concept. But the thing is that classes in JavaScript are not at all like in other languages. So we are using the class word for something that doesn't really behave as you would expect from a class. And that's weird. Let's see how is that. Going back to our counter class example from before, let's say we create an instance of our counter with 0 as the initial value. And now we call the increment method, then we check the counter value, and it's now 1. OK, great. We went from 0 to 1. This is working. But what happens if I now do this? Because as you might know, classes in JavaScript are basically syntactic sugar over prototypes. So first notice how I can actually access the underlying prototype. This is a pretty abstraction, to say the least. But besides that, the thing is that prototypes are living objects that are referenced from the instances, the other instances. Like the prototype is a living object, is an instance itself. So if I change the prototype like this, even though the counter instance was created before we did this change, it is affected anyway. So if I now call increment, my value is 0, because I changed the prototype, so it's going back to 0. So yeah, this is a little bit weird if you ask me. It doesn't really match what you would expect. Because typically, a class defines a type, which is later instantiated and runtime. Whereas prototypes in JavaScript, as I said, are living object instances themselves that are then referenced by other object instances. And living is the key word here. Unlike classes, definitions in prototypes are not statically copied at declaration time. So you can modify them, and the changes that you do will affect previously instantiated objects. And again, since classes in JavaScript are syntactic sugar over prototypes, they behave this way as well. So this is pretty weird. Like we are using, as I said, we are using the class word for something that doesn't really match our expectations of what a class is supposed to be. And then there are other problems. Notice how can I access the value field here from outside? Because it's not, the value is not private. I mean, you would expect it to be, or we would want it to be private, so we can only retrieve it or set it with setters and getters, but that's not the case. And that's another issue with classes in JavaScript. They do lack a lot of features that you would find in other languages. You don't have private members. You don't have private methods or properties. We don't have static members either. We don't have other things like decorators, for example. And there are proposals for all these things, but they're not part of the standard yet. And they will likely take some time to land, as they're tricky to implement on top of prototypes. And if you use TypeScript, you do have some of these things. You have public protected private fields and methods. You have read-only prototypes. You even have abstract classes. But that's in TypeScript. That's not in the JavaScript standard. And the way TypeScript implements all these things is actually very different from the way it's been discussed right now for JavaScript. So it's going to be some time until all that stabilizes. And honestly, I'm not even sure personally that we want or need some of these things, like, for example, static methods. Static methods make sense in languages like Java, where everything needs to be a class. So it's like there's no other way to do it. But in JavaScript, you just can define a standalone function and use it from whenever you need it, including from inside a class. So there are, I mean, I'm not saying there are not valid use cases at all. There are some, but it's not as important as you might think. And then, besides this, we have the context binding problem. Handling the this keyword in JavaScript in classes is confusing and really error-prone. And these kind of problems with context show up with asynchronous code, which is basically everyday code in the browser. So you bump into this all the time if you're developing web applications with JavaScript. Let's say now that we have a button class that just gets a click handler. And we instantiate our previous counter, and we use the increment method as the click handler from the button. So the idea, of course, is that whenever you click on the button, the counter is incremented. Well, it turns out that the counter is not actually incremented. If we look at the button instance, we can see that it has a value property in it that is not a number. What the hell? As some of you might already know, what's happening here is that the increment method of the counter is using the this keyword inside of it, because it's doing like this.value ++ to increment the counter. But the keyword in this line, in this context, is actually the button, not the counter. So what is happening is that button.value is undefined, so undefined +1, not a number. Yeah, again, expectations not quite matched. This is weird, and you bump into this all the time. So we need to bind the increment method to the counter instance. So, OK, there are ways to do it. Like, we can do it on every call, either with a bind method on top or with an arrow function. But sure, this is error-prone, because we have to do it every time. We have to remember. So, OK, we can move it to the constructor. This is safer. But we can argue that maybe the syntax is not very nice. OK, that's fine. We can use a proposal for JavaScript, the class fill arrow function proposal, which lets us do this. It's doing the binding on the constructor thing that we saw before under the hood, but it's like a syntactic sugar. It's nicer. So, OK, we could say this is more or less fine, but the thing is that no matter what the way you do the binding, if we look at the counter of the prototype of the counter, we'll see that we have the constructor and we have the reset method. But we don't have the increment method anymore. And you might be thinking why, or you might be having the answer. And this is because the increment method is no longer a class method. It's an instance property. So going back to what we're doing, we are basically creating an increment property on the instance, not on the class. It's not a class. Every time we instantiate a counter, we are adding this property and binding it to the method in the class. So yeah, the increment method, it's added as a property to every new instance in the constructor in runtime. So again, classes were supposed to be a blueprint, and instances were supposed to reference the class methods. But the truth is that here we are creating a new function for every instance. So more weird things with classes. It could also have some performance implications, because we are effectively creating new functions all the time with every instance. But I'd say that's really, really minor compared to some of the other problems that we can have, the error proneness of things. And finally, on top of all this, classes are harder to deal with for tools. Classes don't minify very well, which is important because your application will be, the bundle of your application will be larger. For example, automatic dead code removal is tricky with class methods. It doesn't work as well. That just removing unused functions, which is much easier. And classes are also not very friendly to some advanced techniques either, like ahead-of-time compilation. It makes it harder, or hot reloading, which makes it unreliable. So it's not only the ergonomics of using them and needing to remember to bind methods and all that. It's also that tools are not as easy to optimize with tools. So OK, after all this, let's say that we might want to avoid classes, at least sometimes, because of the problems we've seen. But surely we don't want to go back to prototypes, because after all, as we've seen, classes are just syntactic sugar on top of them, and so we get the same problems, but only with a worse syntax, so we don't want to do that. So what's left then? Well, what's left are just simple functions. We can take advantage of core fundamental features of JavaScript, like closures, to do sort of similar things to what we do with classes, but only with functions. Maybe changing like with a different mindset, but it's more or less the same thing. We can actually emulate object-oriented programming features that are typically implemented with classes, like inheritance, encapsulation, or polymorphism. And we're going to see how. And also common design patterns, like factories or singletons. So let's take a look at how we can leverage closures in particular to do these things. So first of all, closures help with encapsulation. This would be the equivalent of our counter class from before. This is just a factory function, a function that returns an object, an instance. And first notice how we don't need to save the initial value anywhere. There's no instance to save the initial value because this is all, they are not different, there's not a constructor and then different methods. Everything is in the same scope. So we can access the initial value that it comes as a parameter from our reset property right away. We don't need to do anything. We don't need to save it anywhere. And also notice how the counter value is now private. We are just creating a variable, assigning it the initial value, and then in our getValue method, we are reading it. So from the outside, we cannot read value directly because it's scope to this function, but the return object will keep the reference by virtue of the way closures work in JavaScript. So we are doing what we were doing before, but just in a different way and with avoiding some of the issues. So sure, and one thing is that you might be thinking that, OK, the problem is that we are now creating new objects all the time. There are no references because there's no class. But that already happened when we had to bind some methods in classes. So, I mean, I would say this is not such a problem, because in return, we get actual private members. And we also avoid issues with the this keyword, because we are not using it, basically. In fact, if we look at the button example from before, we can replace it with this, a create button factory function, and everything works just as expected. Again, due to the way closures work. So we don't need to do any binding. We don't need to do anything. And you might be thinking that this is like a very contrived, simple example that it's not really useful in real life. But I'm sure you've all seen something like this, a movie API class that just encapsulates methods to access an API. And it can have, for example, an add favorite method. So the idea is that in the constructor of the class, you get the token, because you don't want to be passing the token around to every method. You just create an instance of the class with the token. The token is binded to the instance. And then in your method, you just you can reference it with this.token. So this is great. And then you use it just like that. New movie API, you pass the token. That's not a real token, of course. And then you call your add favorite method. Well, we can do the same thing with functions. You can have a create movie API factoring function that gets the token as a parameter. And again, you don't need to save it anywhere. And you can just use it in the property of the object you're returning. Same thing, very similar, little bit of a different concept, but you can do the same thing. And instead of doing new movie API, you just call the create movie API function. It doesn't change much. So object composition is another powerful concept that we can use. It helps us implement similar patterns to inheritance and polymorphism, although, again, with a different thinking model. So this is a create base counter factory function. It is almost like the create counter that we saw before. The difference is that instead of the increment method, it has a set value method. Because what we're doing here is having like a sort of a base class. It's not a class, but something similar, that we will then extend to get our actually useful counters. So here we just have the basics, like the method to reset, to get the value, and to set the value. And the value is private there. So what we can do with this is we can create our step counter on top of it. So the only thing we do is we call our base counter with the initial value, and notice how we get everything, every property of the object, but the set value, because we do not want to expose the set value. We want to use it internally, but we don't want it to get exposed. So the object we return has every other method, the reset, the get value, and then we add an increment method that is in turn using set value. But do notice how we are not exposing the set value. So we have it in the base counter, and from the counter that inherits from the base one, we just call it, use it internally, and then return whatever we want. So we are achieving something similar to inheritance. And if we wanted to override a method, so to speak, we could do it as well, because this is an object. So if the create base counter had some method and we wanted to override it, the only thing we need to do is add a new method to the object, and it will be the way JavaScript works. If we already had a key with some value and then we add the key with the same value, it will get overridden. So you can effectively do the same thing. So more things that we can do. Function composition and higher order functions, and some other resources that we have in our functions toolbox. And we can use them to implement similar patterns to decorators or mixins. Let's look at this example. This is a with login decorator, and it's a higher order function. A higher order function, if you don't know what it is just a function that returns another function. It's as simple as that. So this function is getting a method, and then what we are doing is returning another function that gets some arguments, console logs them to the console, that's why it's called with login, and then call the original function with the same arguments. So we can use it just like that. We call with login with our original function, and in return we get our decorated function. And sure, I mean can be a little bit more verbose and more explicit than using decorators in a class, but it achieves the same purpose. And finally, in modern JavaScript, we also have modules, and they provide encapsulation, again, in a similar way to closures, and can also help implement some design patterns as well. For example, a singleton. This is our counter example, but it's now a singleton. And notice that what we are doing here is we have a variable with the instance, and the only thing that the module is exporting is the create singleton counter function. And all this function does is it gets the initial value. If we don't have an instance yet, we create the counter and we save the instance. And if we had it already, we just return the previous instance. And the instance cannot actually be accessed from the outside because we are not exporting it from the module. So this would be a simple way to do a singleton. If you wanted to do a singleton with a class in JavaScript, it's a little bit tricky. You can look it up. You have to do sort of weird things, again, that here you don't need to. It's just very straightforward. There's nothing weird with it. So, OK, as I said before, is this just some crazy thing I'm saying? You shouldn't believe me, maybe, because the fact that I'm talking here doesn't mean anything, so I might be completely wrong. Is really something happening around in the community with classes? Well, we're going to see a couple of examples, as I said, of popular JavaScript frameworks that are moving away from classes. And the first example is React. React already had classes. Components were initially being created with functions, and then they introduced a class-based API for them some time ago. So one of the problems with this is that if you had a function, a component written as a function, and then you wanted to add a state, for example, you needed to rewrite it as a class. It was a pain in the ass. But now they introduced this thing called hooks that basically lets your functions be stateful. It allows them to have state and to have side effects. And it's something we won't focus much on the syntax because this is more generic JavaScript talk. It's not much about the frameworks, but I wanted to give you a couple of examples of this. So this is a counter. You know how this counter works by this point because it's always the same sample. And we are using this use state hook that React provides to create a state. And we pass the initial value, and it returns the value of the counter, and then a method to set the value. So then in our render, we use it right away. And also, we have a button to increment it. And notice how there's no this involved, there's no binding, there's no everything. And it's due to the same reason we've been seeing before. Everything is in the same closure. It's a function, and there are no separate methods. Everything is together. So we can access the counter from the return in the render part, and everything works. We don't need to do anything special. So this is taking advantage of closures. And actually, one of the problems with learning React hooks, when React hooks were announced, one of the problems people were having trying to wrap their heads around them was that some people was not as familiar with closure, so they were finding some weird issues that actually had to do with the way closures work in JavaScript. But React is not the only example. Vue is another popular JavaScript framework, and this is a really interesting one because they actually didn't have classes before. They had like the way to instantiate their components was you call some create component method from Vue, I think it's called, and then you passed an object. So at some point, I think last year or 2017, I'm not sure, I think it was last year, they came up with a proposal for a class-based API to write components in a similar way to React. And it actually came like from the language creators. And what ended up happening is that they started to find out all these issues we've been talking about, and the proposal was finally dropped in favor of something that they call Vue Composition API, that it's going to be released in Vue 3, I think. And it's actually inspired by React hooks. So if you look at it, it's really similar. I mean, it's done in the Vue way, but it's pretty similar. You have a setup method that gets the initial value, which is a property of the component, and then you call view reactive to let view know that, hey, this is a reactive value that I want you to be refreshing my template when it changes. And then you just use it in the template. And for incrementing the counter, very similar idea. So this is, again, taking advantage of the same things we've seen of closures. And besides all the things that we saw with classes, the people in these frameworks coming up with these ideas with hooks, and then Vue, especially in the case of Vue, actually dropping the proposal for using classes. They find out some things in the process that are particular to component frameworks in JavaScript, but that have to do with classes. One of the things they find out is that using functions this way leads to better logic organization. The problem with class-based components was that concerns were mixed. Because if you had, for example, a component that when it's mounted, does a network request, and then adds an event listener for when the user moves the mouse, let's say, then on the unmounting of the component, you will need to remove the listener, and maybe you will need to do something else with the data. So the problem is that we were grouping things not by the feature, but by the moment in the lifetime of the component in which they happen. So you have like a component in mount that does these two things that are two independent features, and then you would have code from those scattered all around the class. Whereas with an API like this, if we go back to the Vue example, there in the setup, what you have inside, it's nothing special. They are just regular JavaScript functions. So you could get all this extracted to a class and call it useCounter, for example, and then just call it from the setup. And in that function, you can encapsulate everything, and you can use the different, you can hook onto the different life cycle methods of the component. So you can actually encapsulate things by feature and not by some random thing, which is the moment at which things happen. So that's one thing. Also related to that, they found that classes lead to more convoluted patterns. Because if we wanted to do something like I've said, we wanted to group things by actual features and not by the life cycle methods. What are our options? Like we could write a component that does all the things related to the counter in the mounting of the instance, and then in the render, and then in some other place. But components need to return some render. So then you have the problem of some convoluted patterns, like maybe you've heard about them, like higher order components, or mixins if you're using classes. And those are more complicated and more difficult to follow in general, because if you're using mixin, for example, the sources are unclear. If you are getting properties in your component injected by these mixins, you don't really know which property comes from which mixin. And you can even have problems with clashing of the names, because two components could be using, two mixins could be using the same names. So it's really not pretty. And a solution like this that uses functions in a composable way, it just leads to simpler code in general. And finally, another advantage of using these patterns is that these are more type-friendly. Because they are mostly, as you saw, we are using mostly plain variables and functions. We are not doing anything fancy. So they are easier to type for if you're using TypeScript or Flow or any static type checker in JavaScript. It's easier to actually type them manually, but also type inference works much better because they are just functions getting arguments and returning things. It's not as complicated as if you had to use, as I said, like a high order component, a component that returns another component, or that injects some properties. Because then you need to, in your type declarations, you need to be writing types that mix the properties that come from your original component with the ones that come from the mixing or the other component. It's a mess, and it's much more difficult to do. And on top of these benefits are particular to frameworks JavaScript frameworks for components in particular, but all the benefits, they also reap off all the benefits we mentioned about using functions instead of classes, like the bundle sizes. This minify better. Actually, last version of Vue is like half the size of the previous one. And this is partly one of the reasons. OK, so that was a lot of stuff. So let's do a quick recap of the main points we've talked about, so at least you can remember something from this. So to me, the most important thing, and if there's just like one thing I want you to remember from this talk, is that you need to adjust your expectations when working with classes. I'm not saying you shouldn't use classes in JavaScript. I'm not saying they are terrible. There are some nice things about them. But we need to remember that classes in JavaScript do not work as in other languages, as we've seen. And if you are working with them on a regular basis, maybe you should learn a bit about the prototypes behind them if you don't know about that. Because they are right there. I mean, you bumped into the issues very frequently. Also, watch out for issues with context and the this keyword. Remember to bind your methods when dealing with asynchronous code. And look out for encapsulation issues as well, as we saw, that we have no private members just yet, only if you're using proposals or if you're using TypeScript. And above all, we just might want to consider using functions. Maybe not all the time, but I see a lot of times when people, as I said, especially people coming from other languages, they are really used to classes, so they write everything with classes in JavaScript. And there are, again, there are valid use cases, but sometimes they are overused. And you might want to step out for a moment and think about if you really need a class to achieve what you're trying to do. There might be performance implications. Maybe you have like tons of instances, and referencing is really a thing that is going to be beneficial. It's really uncommon. Like you really need to have like a lot of instances for that to be a problem, but it could happen in some applications. Or maybe classes are imposed by your framework of choice. As we've seen, that's actually going the opposite way, at least with React and Vue, but some frameworks still make you use classes. But unless those two things are of consideration, as I said, maybe we should be using functions more. Closures, modules, object composition, function composition, they are all powerful things. And they feel very natural to the language. As we saw, they just read very easily. And in fact, things like closures are so fundamental to the language that you're going to have to learn them anyway. I mean, you can't really work efficiently in JavaScript without really understanding closures. So if you're going to learn them, you just might as well take full advantage of them. So that was it from my side. Thank you. I think we might have some time for questions, because it took me 40 minutes, so we have still some time if you want to ask anything or tell me how wrong I am, which is also a valid thing to do. By the way, I didn't mention that. That's my Twitter handle. My DMs are open, so if you want to talk to me, you can just write. You don't need to follow me or anything. You can just drop me a line, and I'll be happy to talk. Yeah.
First of all, thank you for the presentation. It was very interesting. I really appreciate the ideas that you showed. Second, and this is not the main question, but are the slides available for us?
Sorry, I don't hear the sound very well.
Are the slides available?
Oh, yeah, sure. Sure. I mean, I can tell you the URL, but it's long. But you can watch out for my Twitter. I'll post the link after it, and I'm sure the Twitter of the conference will retweet. So I will be posting them. Yeah.
Okay, and one more question. When you were talking about the need to bind the functions, the methods inside a class, and you were saying that it's a problem because those binded methods won't be part of the prototype, they will be part of the instance. Couldn't you bind them to the prototype? Like say class.prototype.inc equals, and then put the binded method.
Mm-hmm. I mean, yeah, you could do, you can solve that in some ways. As a matter of fact, since we were talking about React and how they handle classes, at some point they actually consider do auto binding for you, and in Vue, in the proposal for classes that was then dropped, they were actually doing that. Like part of the proposal was, okay, like we are going to bind the hell out of this because we don't want people to think about this because it's like, I mean, I know about this stuff and I bump into it all the time and I'm seeing all the time. So yeah, there are workarounds, but to me they're just workarounds. So you can do things, but it's not pretty. Like even if you don't do it, like it might look fine to you, but there's like a lot of shit going on behind that you're just not seeing because the framework is doing it for you. But someone is doing it still.
Okay, thank you.
Hi, as well. I really like the talk. It was interesting.
Thank you.
Not in the idea that I don't agree with you, but I think, well, we all know, I think Angular is missing there because Angular is, first of all, more object-oriented than the other ones. That's one reason, but the other one is dependency injection. And I think dependency injection, Angular using dependency injection really with the core of it, are avoiding a lot of the problems that usually, well, with high order components, for example, in React and so on. So yeah, it's really cool, but as well, using object-oriented way with dependency injection also gets you there, I would say. But there are pros and cons, of course.
Yeah, it's true. I mean, I think the Angular case ties in with what I was saying about TypeScript, because Angular is using TypeScript. So they are doing dependency injection, and they're taking advantage of things like decorators. And I mean, it's fine for now, but I'm not like as someone that cares above all about JavaScript and the standard, and then frameworks come to me as a second interest. The problem I see with Angular using TypeScript and using all these features is that we don't know what's going to happen to them, really. Like, TypeScript wants to be in sync with the spec, but again, the way they've implemented decorators and private members and everything is really very, very different from what the ECMAScript standard is trying to do. So I'm sure they're going to converge at some point, but it's going to be down the road. And I hope they don't it doesn't mean changing the API in a big way, because we know the story with Angular. So I'm a little bit concerned about that. So, but yeah, it's like I'd say Angular is the paradigmatical example of a framework using classes in JavaScript in a nice way, and you don't need to care about most of these things. But as I was saying to the previous question, you don't need to care about it because someone else is taking care about it. So it's nice, but on the other hand, it's like the framework and TypeScript in this case is basically preventing you from doing that work, but someone is doing that work somewhere.
Thanks.
But yeah, see, I mean, if you use Angular, you're fine with classes. That's yeah. There's another question there.
I'm wondering if you have a rule for deciding when to use a class and when to use a function. For me, hooks seems like a case to use it when you have like 1 or 2 or 3 things on state, but if you have a larger state, it doesn't seem something that you can use easily, or if you have a mixed application with hooks and functions and classes, doesn't get overwhelmed for developers?
Yeah, I think it depends on if you're if you're writing JavaScript for the server or the browser, or you're using a component framework or not, that depends a lot. In the case of component frameworks that don't require you to use classes, I would say, as of today, like you don't ever need to use a class, because like that, it gives you no benefits over using the React hooks or the view composition API thing. If you're writing plain JavaScript, sure, there are instances. If you have state, you maybe want to use a class. It depends. It's also a matter of personal taste, I think. It also depends in the way your class is going to work. If you are going to do a lot of async stuff, you are going to bump into the binding problem. So you can use a class, but you need to be aware that you are going to have to be binding the methods and everything. If it's a class that has methods that are all synchronous, I think it's fine. It depends. I don't have a general rule, unfortunately.
But for a React application?
For a React application, we don't use any class at my. I use React on my day-to-day work, and I don't think we have any class in our code base. It's a relatively new code base, so we had hooks already. So we started using them, and we don't use any class. I don't think so. No.
Okay. Thanks.
So yeah, you can live without classes actually. Okay, I think there are no more questions. Okay, I'm going to be around all day, so if you want to come talk to me about this or my company or whatever I've talked about that you found interesting, please feel free to reach out. So thanks again.